Welcome all of you. Myself Dasarwar Rahul Rajkumar. I am working under the supervision of Dr. Manish Deshpande sir. Today I am going to represent my one of the research topic, which is synthesis and characterization of mesoporous materials MCM22 using rice husk ash as a silica source under the different temperature states, the green aspects. Next is my research paper is mainly divided into the 5 parts, which is introduction, experimental, result and discussion, conclusion and references. So next is introduction. In India, annual production of rice husk is about 55 million tons. In some areas, a large amount of rice husk is considered as waste and is dealt with the land. Therefore, there is an urgent need of widespread use of rice husk. The content of unaccrued silica is rice husk are the highest, about 20 weight percent in all the villages, which makes it possible to use rice husk as an alternative cheap source of unaccounted silica for the production of silicon based materials. Several studies have been shown that rice husk is an excellent source of high range unknowable silica, SiO2, which is the basic raw material that is widely used in electronics, ceramic, plastic, rubber and photoelectric material industries. In various applications of rice husk silica, there is a significant interest in the use for the preparation of zeolites. Next is experimental. Materials and chemicals. Rice husk was obtained from a local rice mill in Nanded district. The content of silica was 89.2% in rice husk ash and 16.7% in rice husk. Rice husk as preparation and chemicals for the MCM22 synthesis were of analytical grade and were purchased from Crescent Chemical, which is in Hyderabad. Cationic brilliant red molecular formula, which is C23H26Cl N3, which is having maximum wavelength nearly 510 nanometer and molecular weight is 344.48 was obtained. The purity of the dye is greater than 98%. The structure of CBR is painted in the figure. Next is the preparation of rice husk silica. Rice husk was washed thoroughly with the distilled water to remove the adhered soil and dust and dried at 100 degrees Celsius overnight. The dried rice husk and HCl solution 3 molar were mixed under the stirring in a glass round bottom flask at 100 degrees Celsius with the thermostat for 2 hours. In order to remove the alkaline impurities, the solution was filtered and the husk was washed repeatedly with distilled water until the filtrate was neutral. After the acid treatment, the rice husk was pyrolyzed in a furnace muffle and the rice husk ash was ground and passed through 300 mesh sieve. The ash was put into the 3-naked Teflon flask with a reflux condenser and the sodium silicate solution was extracted by refluxing rice husk ash in 2 molar NaOH solution at 80 degrees Celsius for 4 hours. Under the vigorous stirring during the Boone reaction period, the suspension was filtered and the solid residue was soaked in 3 molar HCl solution for 20 minutes under stirring condition. The result, white silica was washed with hot water. The temperature of the whole filtration process was kept at 75 degrees Celsius. Silica was gathered and ground in an agate mortar till white silica powder was obtained. So this is the chemical structure of cationic brilliant red 5GN dyes. Next, which is the extraction result of the silica for all 9 experiments are depicted in this table. So in this table, the volume by mass ratio is given, and next is NaOH concentration, which is in mole per liter, reaction time, temperature and productivity is mentioned in this graph. Next is the results and discussion. Effect of parameters on silica yield. According to the analysis of extreme difference, the value of K and R were calculated by statistical software and are presented in this table 1. The factors that affect or influenced the productivity percent of rice husk silica are listed in a decreasing order, which is A is greater than B, is greater than D, is greater than C in a view of R value. In addition, according to the value of K, the maximum yield 92.6% of rice husk silica was obtained when the ratio of NaOH solution volume to rice husk mass, NaOH concentration, extraction time and extraction temperature was 32.5 mole per liter, 3.5 R and 300 degrees Celsius respectively. Next, which is characterization of rice husk silica. The major component of the rice husk silica was SiO2 with purity 98.5% along with a small amount of other inorganic oxides including Al2O3, K2O, CaO, CuO, Na2O and Fe2O3. The silica purity was significantly sufficiently to use a silica source for the synthesis of MCM22. The XRD pattern of the silica powder is shown in the figure. Only a broad peak with 2R at around 22 degree was observed, which is shown in this graph. It was typically amorphous structure and absence of any ordered crystalline structure indicated relatively high disordered structure of rice husk ash. In this graph, the XRD pattern of the silica produced from rice husk is given and particle size distribution of silica produced from rice husk is also given. Next is the same image of the silica produced from the rice husk and the high resolution 10 image of the silica produced from the rice husk is shown in this figure. And similarly, the powder XRD pattern of the calcined MCM22 is also mentioned in this figure. The XRD pattern of the material agreed well with that of the corresponding materials. The smooth baseline and narrow half peak breadth indicated that there were no non-crystalline. The calcined MCM22 sample exhibited several sharp diffraction peaks and had a same representative diffraction peaks of 2R value, which is 6.1 degree, 8.2 degree, 9.3 degree, 13.8 degree, 22.1 degree and 26.3 degree. In addition, there existed a long trailing peak after the 2R value of 26.3 degree, indicating that the complete formation of interlayer oxygen bridge, which is shown in this figure. These diffraction peaks were consistent with the characteristics diffraction pattern of the typical MCM22 molecular sieve, indicating that the prepared material was MCM22 zeolites with a good crystallinity. Now next, the same image pattern of the calcined MCM22 which is shown in this figure also, and next same image pattern of the calcined MCM22 also is shown in this figure. Now next is conclusion part. In this study, the amorphous rice husk silica was used as a silica source of MCM22 synthesis by the hydrothermal method under the varying temperature conditions. The crystallization time of MCM22 was reduced from conventional 9 to 12 days to 3 days. The adsorption of CBr onto the MCM22 was found to be dependent on pH, contact time and adsorbent amount. The result obtained in batch adsorption of CBr onto MCM22 showed that the adsorption kinetics should be explained by the second order equation better than Lagrange's first order. These are my references. Thank you. Hello. Path with the detail. Detail path with the.